Good morning, Year 10. I hope you can hear me over the sound of the fan that's keeping me cool in this stifling hot classroom. Last lesson today, well, last video today, I'm going to set you a little puzzle tomorrow, but that's just optional. But I am going to assume you've done this, and it's it's an important skill and technique. So please make sure you've caught up if you are a little bit behind. So you won't be surprised. We've done simplifying algebraic fractions, we've done multiplying and dividing algebraic fractions. Today we're going to look at adding and subtracting algebraic fractions. I want to start with just talking about numbers. We know, don't we, that when we have to add two fractions, we need a common denominator. Sometimes it's simple. So here, for example, if I do 3 times 4, I get 12, and so that's the common denominator I use. To make 3 into 12, you multiply by 4, so I do the same to the top. And to make 4 into 12, I multiply by 3, so I do the same to the top. So that gives me, and hopefully you remember that that's the same as 1 5/12. Sometimes you have to think a little bit carefully. I mean, actually, if I do 6 times 9 and get 54, I could do this with a denominator of 54, but I don't need to. The easiest denominator to use is 18. Because in truth, when we're choosing a common denominator, we're actually looking for the lowest common multiple. You may remember LCM from back in year 9, but we're looking for the first number in both times tables. So to get 6 into 18, you multiply by 3, same to the numerator. 9 into 18, you multiply by 2, same to the numerator. And there we go. And the same is true with algebra. So sometimes when we add algebraic fractions, the denominator is obtained by just multiplying the two denominators together. So in this case, I'm going to have a denominator of this. To turn this into this, I have to multiply by x minus 2. So I'm going to multiply the top by x minus 2. And to turn this into this, I multiply by x plus 1, so I'm going to multiply the top by x plus 1 as well. So that's going to give me a single fraction. I'm going to have 2 lots of x, that's 2x. And 2 lots of minus 2 is minus 4. And I've got 3 lots of x and 3 lots of 1. So finally, to sort it all out, I've got 2x plus 3x, which is 5x, and I've got minus 4 plus 3, which is minus 1. Sometimes you just need to be a bit careful. I'm not going to use x cubed as a denominator here, because actually I can use x squared. That fraction just stays the same. And to turn x into x squared, I just multiply it by another x. So I'm going to do the same to the top, 2 times x. So that gives me end of. Now I know that algebraic fractions look a bit more scary, but actually all we're doing here is the same as we're doing here. We're finding the lowest common multiple, and whatever we've done to the denominator we do to the numerator, and then we're able to write it as a single fraction. I wonder if we could speed this process up a little bit. So the downside of all this malarkey, and the one we just went through, is you end up writing this denominator loads of times. So I wonder if we can speed that process up a little bit. So I know that this fraction is going to end up with a denominator of x plus 3, x minus 4. Just like here, we had 3 and 4, it became 12. I know when I've got x plus 3 and x minus 4, that's going to be my denominator. Now, rather than writing it as two separate fractions, I'm going to skip to the whole fraction stage. I've got two fractions, so I'm going to write them either side of the plus sign. So to turn this into this, I multiply by x minus 4. So I'm going to do the same to the 4. I'm going to multiply that by x minus 4 as well. And to turn this into this, I'm going to multiply by x plus 3. So I'm going to multiply the top by x plus 3 as well. And I'm even going to skip another step because I can do most of the simplifying in my head. So I've got 4 lots of x and 7 lots of x, so that's going to be 11 lots of x. I've got 4 times minus 4, which is minus 16, and 7 times 3, which is 21, minus 16 plus 21. End of. And it's this sort of fraction addition sum that I just wanted to practice today. Sometimes people refer to this as an upside down picnic table because you end up with a denominator that's those two multiplied together. The 4 needs to be multiplied by x minus 4 and the 7 needs to be multiplied by x plus 3. Now, I don't know, I'm not a huge fan of tricks like that. I'd much rather just understand why we do that, but it works, doesn't it? The 4 has been multiplied by that, the 7 has been multiplied by that, the denominator becomes those two things combined. So let me just give you a few to try along similar lines. Okay, 3 for you to try. This one, just like the one we've just done. This one, yeah, the same. I mean, the fact that's just an x doesn't make any difference to the process. Just got to be slightly careful with this one because it's subtraction. And you just got to be therefore careful with the minus 2 on this side. But pause and have a go, and I'll come back and go through the 3 of them in just a moment. Okay, so with the first one, I know my denominator is going to become this times this. To turn x minus 5 into x minus 5 times x plus 1, I need to multiply by x plus 1, so I do the same to the top. A plus sign there. To turn x plus 1 into this, I need to multiply by x minus 5, so I have... And I'm going to do the last bit in my head. 5 lots of x here, plus 3 lots of x there, gives me 8 lots of x. 5 times 1 is 5, and 3 times minus 5 is minus 15, so 5 minus 15 is minus 10. Here, same thing, slightly easier denominator, so I've got to turn that into that, I need to multiply by x minus 7, sorry. And to turn this into this, just need to multiply by an x. So I'm going to multiply the numerator by x as well. So it's a bit simpler. So I've got 7 x's and 4 x's. And I've got 7 times minus 7, which is minus 49. Now this last one you had to be a little bit more careful. So I've actually done 3 steps. You may have done it quicker than me, I don't know. The first step is pretty much the same. So you're going to multiply the first numerator by x minus 7 and the second numerator by x plus 4. This I'm going to do without doing it in my head. So 3x, 3 times x, and 3 times minus 7. Got to be careful now, because I'm not multiplying this bracket by 2, I'm multiplying it by minus 2. So minus 2 times x is minus 2x, and minus 2 times 4 is minus 8, and I wonder if that's where a potential mistake might have happened. You might have just put minus 2x plus 8. You've got to remember that you're multiplying the whole bracket by minus 2. Okay, so I've got 3x take away x, and minus 29. You might be asking, why did I not multiply the brackets here? Well, I mean, you could do, but we generally feel that sort of factorised is a little bit more, well, the word we often use in maths is elegant. Elegant. Okay, so it's hot and sunny outside, and I know you don't want to do a huge amount, so I'm going to give you one more question for this year. Can you believe it? And let's see if we can have a go at that. Okay, the first thing to say is that often these questions are not phrased as add these fractions. They just say this, express as a single fraction. It means add them. And do you remember with last video we had, when we were multiplying and dividing, I said before you do anything, and this was because of Sean's prompting with my mistake with the simplifying videos, make sure you've tried to factorise first. Now we haven't had anything we could factorise up until now, but I've got something here I can factorise. So pause the video and see if you can factorise that denominator, and then see if you can notice what that actually means. We've come across a problem like this already in a much simpler form, Pause and have a go. So did you spot that this can be factorised as x plus 1 times x plus 2? It's a fairly straightforward factorising. Remember I said the other day, it doesn't really matter whether you have brackets or not. I tend to put the brackets in, but you don't have to. So what, when I add these, am I going to use as my denominator? Am I going to just multiply the two denominators together and have x plus 1, x plus 2, x plus 2? Well, hopefully you can see that I don't need to. It's a bit like the one where we had a denominator of x and x squared right at the start. I can use this denominator. I can leave this fraction unchanged. I can just leave it as x over that. This fraction here, to turn x plus 2 into x plus 1, x plus 2, I need to multiply by x plus 1. Now I said I don't necessarily need to multiply out the brackets, but I would here, because I have a feeling there's a bit of simplifying going to happen here. So here we go. I'm going to leave the denominator factorised, but I recognise this. I know that this is one of those difference of two squares ones, where when you peanut you're left with no x's, so you actually get x squared minus 1. Now, okay, that's not lined up properly, but I'm going to leave it like that. X squared plus x minus 1. So that problem there becomes this answer here. Okay, so there we are, the end of year 10. What a year we've had. What 2 years we've had. We've laughed, we've cried, we've done a lot of videos, we've had some good times in the classroom, and I look forward to seeing you in September. You know, it's tempting to say next year, but of course it's 6.5 weeks away. And I do hope you have a great rest. I hope you've kept up with these. I suppose if you're watching this point in this video, then you will have done, so well done. As soon as I finish this video, I'm going to give feedback to those of you who submitted work, so thank you for that from yesterday's video. And yeah, take care and stay safe. What am I thinking? It's Thursday, so we need a Thursday joke. Well, I don't know if you watched Jeff Bezos go into space briefly earlier in the week, but apparently he's now opened a restaurant on the moon. Apparently the food is amazing, but it's just got no atmosphere. Take care. See you in September.